Today we're going to talk about Bernoulli and binomial distribution. First, I'll introduce Bernoulli distribution, its PMF mean and variance, its relationship with binomial distribution, describe the binomial distribution, its PMF CDF mean and variance, and finally we'll go through some more examples about them. So now let's begin. Here's the definition of Bernoulli distribution. It's just a random variable which has only two possible outcomes, 1 or 0. Let's see what kind of event in our daily life will perform Bernoulli distribution. Toss a coin, which may have two possible outcomes, head or tail. Roll a die, to see whether the result is odd or even. Or draw a card and see its color. The result of these events will follow a Bernoulli distribution. Probability mass function of Bernoulli distribution is like this. The probability of k equals to 1 success is p. Since there are only two possible outcomes, so the probability of k equals to 0 failure is 1 minus p. For example, if the probability of showing a head when tossed a biased coin is 0.3, then showing a tail will be 0.7. Mean equals to p and variance equals to p times 1 minus p. Because the probability of 1 is p, 0 is 1 minus p, so the expected value is 1 times p plus 0 times 1 minus p equals to p. The variance equals to the expected value of x squared minus square of expected value of x equals to p minus p squared equals to p times 1 minus p, which is the same as the probability of 1 times the probability of 0. Easy, right? If we repeat the Bernoulli experiment independently for n times, we are performing a binomial experiment. Binomial distribution is the discrete probability distribution of the number of successes in a sequence of n independent yes or no experiments, each of which yields successes with probability p. When n equals to 1, the binomial distribution is a Bernoulli distribution. So what kind of events in our daily life will perform a binomial distribution? Toss a coin 3 times. Roll a die 4 times. Draw a card 9 times. So the PMF is like this, which means the probability of getting x successes in n trials. That is, the probability of successes p raised to the number of successes x, times 1 minus p, the probability of failure raised to the number of failures, which is n minus x, and multiply that by the number of ways we can get x successes in n trials, which is ncx. Since x represents the number of successes, it can only be integer. So x equals to the integers between 0 to n. Here's a picture of binomial distribution when n is small. For example, n equals to 15. When p is small, for example, p equals to 0.2, it's good right. When p is big, like 0.8, it's good left. When p is 1/2, no matter n is big or small, the binomial distribution is symmetric. The CDF of it is just like this, very simple, just add up the PMF of the possible outcomes. Mean of binomial is NP and variance is NP times 1 minus p. We can see that its mean and variance is just n times the Bernoulli mean and variance. Here's the mathematical proof of the mean. An easier way to understand the formula is to use a little example to explain. Let's say we have a probability of successes on an individual trial of 0.3, and we have 20 trials. Then on average, we'll get 6 successes. To find variance of x, we first find the expected value of x times x minus 1. Expected value of x times x minus 1 is x times x minus 1 times PMF. When x equals to 1 or 0, its value is 0, so we sum it from 2 to n. And we divide x times x minus 1 on both the upper part and the lower part. And we set k equals to x minus 2, and after we take out n times n minus 1 times p squared, the remaining part is again 1. So the result is n times n minus 1 p squared. Thus, variance of x equals to the expected value of x squared minus mu squared equals to the expected value of x times x minus 1 plus expected value of x minus mu squared. And we substitute the results that we calculated. And finally, the result will be np times 1 minus p. So now we know how to calculate the probability mass function, cumulative distribution function, mean and variance of Bernoulli and binomial distribution. Let's do some exercise. A biased coin is tossed 6 times. The probability of heads on any toss is 0.3. Let x denote the number of heads that come up. Calculate the probability of x equals to 2. The probability of x larger than 1, less than or equal to 5. Its mean and its standard deviation. First, let's calculate the probability of x equals to 2, which means the result has 2 heads. If we call heads a success, then x follows the binomial distribution of n equals to 6 and p equals to 0.3. The probability of x equals to 2 is 6c2 times 0.3 to the power 2 times 0.7 to the 4th power. And we can use our calculator and find that the result is 0.324135. And the second part, the probability of x larger than 1 less than or equal to 5 is the same as the summation of probability of x equals to 2 plus probability of x equals to 3 to x equals to 5. And using our calculator, we can find out the result is 0.578. And then we'll calculate the mean of the result. Since this is a binomial distribution result, the mean is equal to np, which n equals to 3 and p equals to 0.3. So the result will be 1.8. Lastly, we want to know its standard deviation, so we have to first find out its variance, which the variance of binomial distribution is np times 1 minus p. So it's easy to calculate that the variance is 1.26. SD is equals to the square root of the variance, so it's 1.122. Hope you understand how to calculate this basic statistic data of Bernoulli and binomial distribution now. Moreover, for better understanding, let's briefly go through the relationship between binomial and other discrete distributions. When we repeat the Bernoulli experiment independently for n times, it performs binomial distribution. And when n equals to 1, it's Bernoulli distribution. For binomial, the number of trials is fixed, and the number of successes is a random variable. We can solve questions like, if a coin is tossed 10 times, what's the probability heads comes up exactly 4 times? For negative binomial, the number of successes is fixed, and a number of trials is a random variable. We can solve questions like a coin is repeatedly tossed. What's the probability that the second time heads appears a course on the seventh toss? The differences between binomial and hypergeometric is whether each trial is independent. Usually when an experiment is with replacement, it's binomial, and without replacement, it's hypergeometric. And when n tends to infinity, p tends to 0, and lambda equals to np stays constant, binomial tends to Poisson. Details about the discrete distribution will be described in other tutorial videos. Here's a summary of what we've learned today.
That's all. Thank you.